Hi, I'm Ed Seidewitz. I'm the chair of the OMG's Foundation's Special Interest Group. And this presentation is going to discuss the foundations that OMG uses for building international modeling language standards. Not going to be so much a technical presentation, but a run-through of the past, the present, and the exciting future of how OMG builds modeling standards. The talk will start with just a little bit about what I mean by modeling foundations. Then we will talk about the history of how we got to this point in building modeling language standards at OMG, where we are at the present, 2024, as we make this presentation, and where we are going for the future for the next 2025 and beyond. So what do I mean by modeling foundations? Well, at OMG, all the modeling language specifications are built on a consistent specification called the Meta Object Facility, or MOF, which provides the foundation for constructing the specifications of other languages. Best known family of modeling languages that are standardized by OMG are perhaps the Unified Modeling Language, or UML, and other profiles and languages such as SysML and the Unified Architecture Framework that are built on UML. The UML specification itself is represented using the capabilities of the Meta Object Facility. But it is not just UML that OMG standardizes. There is another popular set of standards around business process and other business architecture modeling, starting with the equally well-known BPMN, or Business Process Modeling Notation, and other related specifications. One of the advantages of having this diverse set of specifications built on a common foundation is that you could provide capabilities built on that foundation that are not specific to any one modeling language, but can be applied to all of them. So for instance, there are additional specifications built on the MOF Foundation for XML metadata interchange, or XMI, for providing a way to exchange information between modeling tools, and various other MOF-related standards, such as the ability to query, view, and transform models, have repositories of models, etc. And there's much more. But that gives you some idea of what we're talking about when we're talking about the modeling foundations, the foundations on which OMG builds its modeling language specifications and related technologies. So let's talk a little bit about the history of how OMG got to the point of having this foundation for a diverse set of specifications. Go back all the way to 1997. At this time, OMG was first standardizing the Unified Modeling Language, and at the same time was providing the initial specifications for the Meta Object Facility. They went hand in hand. And as UML evolved over the next several years, MOF also evolved with various point releases. The big change, however, came in 2005 and 2006. When there was a major revision to the Unified Modeling Language with UML 2.0, and a similar major revision to the Meta Object Facility with MOF 2.0. It was at this point that we really established in OMG a tight connection between UML and the Meta Object Facility. So here's how things stood around 2006. At the time, the second version of UML was specified with two specifications. The superstructure, which was built on the so-called infrastructure. The idea was to allow for the possibility of building other languages on the infrastructure, though that never really happened. The infrastructure used the MOF 2.0 core specification, and the MOF 2.0 core was actually a subset of the UML infrastructure. Now, this is circular, but it is very important that at some point you have to have the ability for, in effect, a modeling language to define itself. And that was done through this MOF 2.0 subset of UML. The UML superstructure was then based on the UML infrastructure and further specified using the meta-meta modeling capabilities, the capabilities of MOF core that it got from subsetting UML to actually specify UML itself. And then various other capabilities were based on the MOF core capability, such as the XMI mapping for MOF to provide interchange capability between tools. But you can already see here that there was a little bit of a difficulty as things got standardized. The MOF XMI mapping was actually based on a slightly earlier version of MOF Core 2.0 than was actually finally standardized. This shows the difficulty of keeping even these foundational specifications all aligned. And you'll see the history since 2006 has been with trying to deal with this as an organization, so OMG could continue to provide this MOF foundation. Because as we go on to MOF 2.1, you could see that what happened was UML started to evolve, but for a number of years, MOF really didn't. MOF stayed with MOF 2.0. You can see here that the UML 2.1 superstructure was based on the UML 2.1 infrastructure, but MOF was still based on the old version 2 infrastructure. And now you started to get at this point in UML 2 some really major additional specifications being built on UML. Just going to use SysML as an example of that because it is going to be important as we move on into the future. But around this time, 2007, SysML 1.0 was established as a profile of the UML superstructure. So you can see the building on the foundations starting to build higher. But we go on now to UML 2.2. Again, we have a new UML superstructure, a new UML infrastructure, but MOF Core was still at 2.0. SysML 1.1 was still on version 2.1.1 of UML. A lot of work started going into getting these things more aligned. If you go to UML 2.3, you can see SysML and the folks working on that made a real effort to keep it aligned with the point releases of UML. But MOF Core kept stable, but we now had this interesting situation where you had SysML aligned with UML 2.3, but UML 2.3 was based on MOF Core 2.0, which was based on UML 2.0, which was no longer an active standard at OMG. This was something that really couldn't continue because it was starting to get brittle because fixes that actually were made in the UML infrastructure in later point releases were not moving into the MOF core. So in the work that went into version 2.4 of UML standardized around 2011, MOF was finally fully aligned with UML. The 2.4.1 superstructure was based on the 2.4.1 infrastructure. The MOF 2.4.1 core was aligned not just with the infrastructure, but clearly with the UML superstructure, which made it a clear subset of the modeling capabilities of UML for modeling the specifications of other languages. Similarly, the XMI mapping came out, the XMI standard came out in 2.4.1, and there was a commitment made as OMG moved forward to keep UML, MOF, and the related MOF standards, especially XMI, aligned as we move forward to additional point releases. And therefore, other standards, such as SysML 1.3 in this case, could be assured that as they moved forward with the new releases of UML, that entire foundation and the support system that came with it would also be updated for the latest fixes and improvements in the UML spec itself. In 2019, we came out with version 2.5 of UML. And you can see that this eliminated that difference between the infrastructure and the superstructure in UML. There was a unified UML specification. There was an effort with 2.5 known as the UML spec simplification. The language was pretty much exactly the same when you put it all together as version 2.4, but the specification was much easier to understand and easier to implement to. And it was now quite straightforward to look at MOF as a clear subset of UML. In fact, though it wasn't formally specified this way, it is fair to think of MOF 251 as, in effect, the profile of UML to use to specify modeling languages, including UML itself, so that all those modeling languages that are specified using this approach can rely on the foundation of XMI and other MOF standards, and various profiles of UML, including SysML and others such as Marte and UAF, could rely on the capabilities of UML. So that's where we got to where we are today. So let's talk a little bit more about, as of 2024, where we are. So UML 2.5 was published in 2013 and 251 in 2017. The 2.5.1 update really didn't affect the foundational organization of UML and MOF. So really, we've had a decade or so of a very stable foundation. On the one hand, there hasn't been any update to UML since UML 251. On the other hand, from a MOF point of view, this means MOF has been very stable as a foundational technology and a foundational specification approach as OMG has expanded the specifications of modeling languages in its suite and provided additional profiles on top of UML. Recently, however, there has been talk within the UML community about how UML could be updated now to better reflect the kinds of needs of the modern software engineering community, agile technologies, new languages, new design approaches. Well, if we did that at this point, we would really be looking at an entirely new major version of UML, UML 3.0. Most straightforward thing to do would say, well, we'll build UML 3.0 on top of version 251 of MOF, just like version 251 of UML was. However, now we're getting back into the problem that we just spent a lot of time resolving with UML 2.4 and UML 2.5. If we specified UML version 3 on the current MOF standard, we would then have it depend on, in effect, version 2.5.1 of UML, because MOF core depends on that. And again, we'd end up with version 3 and additional point releases of UML, which supersede version 2.5.1 of UML, still depending on version 2.5.1. We've learned that we don't want to go back to that situation. So the natural thing to do is to say, well, we also need to migrate MOF. If we're going to come up with a version 3.0, just like we committed when we did point releases of UML, we would also do point releases of MOF core and XMI. If we're going to move and migrate from UML 2.5.1 to UML version 3, we are also going to need to migrate MOF, and whether it's XMI or some other interchange technology, MOF interchange and other MOF related standards, we need to migrate those to 3.0. This is important. It means moving to UML 3 is not just as simple as saying, let's come up with a UML that addresses the needs of the modern software engineering community. OMG has a responsibility to take into account the effect on the foundations of its modeling specification technology and how that is going to impact this rather diverse and large suite of specifications that OMG has based on MOF. But there's another wrinkle in this. Recently, OMG has adopted version 2 of the SysML, Systems Modeling Language. However, version 2 of SysML is no longer a profile of UML. Instead, version 2 of SysML is based on top of a new kernel modeling language. This provides kernel capabilities for building other languages, and in particular, it provides capabilities for better specifying the semantics or the meaning of these languages, not just their syntax or how they're put together, but how the models put together in these languages actually represent what the modeler wants to say about the domain being modeled. And this is done in a very library-oriented approach, where as you can see, the layers built up here, the semantics or meaning is provided in extensible libraries and eventually in domain libraries. So it provides a very exciting approach, not just for specifying the second version of the systems modeling language, but for specifying a new generation of modeling languages within OMG. Well, how does this relate to MOF? The reality is that KerML itself is a MOF specified language. So KerML version 1.0 is specified using MOF core, just like all the other modeling languages in OMG. And SysML version 2 then, instead of being a profile of UML, extends KerML 1.0. So SysML is then also 2.0 is also a MOF specified language. So we're building on the same foundation. SysML 1.7 is the last point release of SysML version 1 as a profile of UML, and the SysML 2.0 standard actually has a technical specification addressing the migration from version 1.7 to version 2.0 models, which is really enabled by the fact that in the end, version 1.7 and version 2 are both based on this common MOF core, this common MOF foundation. Well, how does this affect UML 3? Now we need to talk about the future. Where do we go now? We have a desire to move UML, which has an impact on the foundation. We already have new technology that is coming with SysML v2 that allows us not only to build on the semantic or the syntactic framework that is provided by the MOF foundation, but it also provides important new capabilities for specifying semantic libraries that can be used to build new technology into the future. So if we add UML 3.0 back into this, one of the things that's been proposed is, well, if SysML 2.0 is based on KerML 1.0, then UML 3.0 should also be based on KerML 1.0 and be a peer language to SysML 2.0. Instead of SysML being based on UML, they would both be based on this common kernel. This, however, introduces the same problem as we had before, just with another level of indirection. If we did this, we would have UML version 3.0 extending KerML 1.0, which is specified using MOF, which depends on version 2.5.1. We would have the capability to migrate version 2.1 to 3.0, but we would still have MOF core based in version 2.1. Well, what's the natural thing to do? Just what we were talking about before we had introduced KerML 1.0. It's we need to update MOF to MOF 3.0. Now we want to do that taking KerML into account. The approach that's being considered now is to move forward by making MOF 3.0 a subset of KerML, probably a KerML 2.0, that would now have a similar relationship to what MOF 2 had to UML 2. So instead of basing MOF on UML 3.0, KerML itself at the kernel has the capabilities necessary to actually provide the modeling framework needed for doing MOF 3.0. Therefore, we could consistently set up MOF based on KerML 2.0, and then base UML and SysML on that. And other languages moving forward could then be built on top of KerML, or they could be built directly on MOF if they decided not to use the KerML semantic technology. So how do we get there? Well, the roadmap going forward is one that has to be journeying over with some care, given the established suite of specifications that OMG already has. The first step is to remove the normative dependency of KerML on MOF 2.5.1. This means looking at what is the subset of KerML that could be used to provide the next generation of MOF 3.0 and respecifying KerML so it is specified on that own subset of itself, just like UML is currently specified on the subset of itself that is in MOF 2. So that's the very first step, and we believe that can actually be done in the next few years, and especially since right now we only have SysML v2 based on KerML, that will provide a step forward that really will only affect SysML v2, but perhaps also open the door then for how we would want to do UML 3.0. The medium term, though, is where we really start making this move and say, all right, now we are going to make KerML an effective MOF3 for the syntax portion. And that's the key thing, is that the MOF foundation primarily is for specifying what's known as the abstract syntax of the modeling languages, how they are put together, how tools construct them, how they are interchanged. The medium-term step is to move KerML to become the MOF3, which means now we need to consider migrating other MOF-based languages, not just moving UML to UML3, but what's going to happen from BPMN and the other business architecture-related languages. What is going to happen to UML profiling, especially major ones such as UAF and MARTE? SysML is already in version 2. The Unified Architecture Framework is actually already looking at moving to version 2 and the relationship to SysML version 2. So this medium term is actually already starting to happen, but it will take a few years to make this careful transition and provide the same kinds of migration and backwards, if not compatibility, but transition capability that is being considered in, for instance, moving from SysML v1 to v2. There's a lot then that could go on in the longer term over the next several years. As we really look at this, the new capability with KerML is the semantic models. While KerML was intentionally set up to be a kernel, to be a basis semantically for more than just SysML v2, in only having SysML v2 as the first client of KerML, there were some decisions made that benefited v2 and maybe were not the best as we start building other languages on KerML. And some discussion is already underway on how to refactor and modularize the semantic libraries in KerML so they could better be reused across, say, a SysML v2 and a UML3. Some capabilities in SysML v2 could be factored out so they could be used in UML for similar kinds of modeling capabilities in systems modeling and software modeling. As we do that, we also really need to look at advanced interoperability. So we have a capability with XM9 now for interchange. There was a new API that was introduced for systems modeling repositories along with SysML v2. There was new file-based interchange capability, which could be used to package XMI, but also JSON and other kinds of interchange files into file-based interchange projects. How do we get that to all work together, not just for SysML v2, but for the coming next generation of languages that will be built on this new KerML and MOF 3.0? And then there are other MOF standards, such as QVT, but also versioning and development lifecycle standards and object lifecycle specifications that have been used to various extents, but are important for really building an entire foundational facility and are related to work that is going on right now in building systems modeling environments for KerML and SysML v2. This is not something that's going to happen precipitously. It's not something that's going to happen just next year, but it is something that we are getting started on. It is a journey we are undertaking with the goal in the end of, yes, looking backwards to understand where we came from and how we built up this capability that's been so successful for OMG, but also looking forward so that OMG remains vibrant and remains the standards organization for the next generation of modeling languages for the decades to come.